you guys look at number 10 and you found your slope, make sure that you always reduce your slope to lowest form. So it was -6/8, so we reduced it to -3/4. And then you may pick either point you want, since they're both points on the line. I chose 5, -2, and I put it into point slope. You could also choose the other point and put it into point slope, or you could even use this middle school method if you choose that. When you get done, you can type this into your calculator or get a common denominator. I left it as 7/4, but you could also have 1 3/4 for that. Okay, so now we're going to look at the second section, which is 3-4, on parallels and perpendiculars. So the slopes of parallel lines are the same, and that's because they rise and run the same. So if two lines are parallel, which we'll talk more about parallel next chapter, but if two lines are parallel, or next section, I should say, then that means that they rise and run the exact same. They never, ever cross. Perpendicular lines, though, perpendicular lines, you might remember, make a 90-degree angle. Those are going to be called opposite reciprocals. Sometimes you'll get books that say negative reciprocals. So negative reciprocals would be another thing that you could do or call it. Okay, so I'm going to show you an example of what parallel lines and perpendicular lines look like. So all of these examples will ask you to list the slope of a line parallel and a line perpendicular to the given line. So we know that this is in y equals mx plus b form. It's in slope-intercept. So go ahead and circle the slope. The slope is always going to appear in front of the x. So my m is 1/5. So if I think about a line going up 1/5, then a line that's parallel will also go up 1/5. So the slope of a line parallel will be 1/5 because they're going to rise and run the exact same. The slope of a line perpendicular will be the opposite reciprocal, which means I need to flip this fraction and make it 5/1, and then I need to add a negative. Now I can add a negative to the top or to the bottom or out front, but the slope of a line perpendicular will be -5/1, or you could just say it's -5. You wouldn't have to put the over 1. So opposite reciprocal means flip the fraction and then change the sign. And that will be perpendicular to the original slope. Okay, so flip your page over. Skip to 14, and we're going to do one together, where it is not in slope-intercept. So we are going to get this equation into slope-intercept. So to do that, we need to get y alone. So I'm going to subtract 4x. So I'm going to get 9y equals -4x plus 11. And I'm just going to put the -4x right in front of that 11. And then I'm going to divide every single thing by 9, including the y-intercept. So I'm going to get y equals -4/9 x plus 11/9. Okay, we know the slope is always located in front of x, so we're going to circle this slope right here. That is my slope. So in the first blank, I want the slope of a line parallel, and in the second blank, I want the slope of a line perpendicular. So if my slope is -4/9, parallel to -4/9 is -4/9. So my slope will match because they run the exact same direction, and it's down 4/9 each time. For perpendicular, I need to flip my fraction and change the sign. So my slope is going to be 9/4, and it's going to be positive because I changed the sign after I flip the fraction, or before, it doesn't matter. It's opposite reciprocal or negative reciprocal. Just make sure it's in slope-intercept form before you decide what the slope is. Okay, now we're going to go down to 16. It's going to say, write the equation of a line in slope-intercept form, so we know it needs to look like y equals mx plus b. It needs to be perpendicular to this line, and it needs to pass through this point. So this is more of an advanced question. Okay, so I'm going to start with point slope. So I'm going to go ahead and write down the point slope equation because we like to use that in high school. So this is point slope. And I'm going to fill in what I need to. So I'm going to fill in 3 things. So my first question is, what point will my new line go through? So if you look, it says my new line is going through -3, 8. So my -3 is going to go in for x sub 1, and my 8 is going in for y sub 1. So that's going to go in here and here. And then I need to look at what my slope is going to be. So my slope of my original line is -1/2. but they said that we wanted a line perpendicular. So a slope of a line perpendicular, well, I need to do the opposite reciprocal from the original line. So I'm going to take that slope and I'm going to flip it and I'm going to change its sign. So when I flip this and I change its sign, it turns into 2, or 2 over 1 if you want. So again, to get perpendicular, you flip and change the sign. Okay, so now I have everything I need. I'm going to put in the 2 and the -3 and the 8. And I want to point out that this 15 right here is garbage, junk, throw it away. So go ahead and scratch it out. That plus 15 is old news. We don't use it because it's the old line. So just get rid of 15 so it doesn't confuse you. Okay, so y minus 8, because that was the y1, equals my new perpendicular slope is 2, parentheses, x minus -3. Oh yeah, it changes signs. That turns to a plus +3. Now I have my perpendicular slope and the point that it goes through. Now it told me it wanted slope intercept, so I have to keep going. This is point slope, and now I'm going to slope intercept. So I'm going to distribute. So y minus 8 equals 2x plus 6. I got that when I distributed. And then I'm going to add 8. Y equals 2x plus 14. That is my new equation of a line perpendicular to my original line, but passing through that point. And you don't use the old y-intercept. Okay, so now we're going to flip to the back and we're going to look at graphing, which is another topic from Algebra 1, but it's also part of geometry. Okay, so when I was talking about the Hoy and the Vux, here's where this comes into play. Which word, Hoy or Vux, has an x equal? Well, the Vux does. So if you look at the end of Vux, there's an x there. So not Hoy, but Vux. So that tells me that I know that this is going to be a vertical line with an undefined slope. So I go to x equals -4 on the x-axis, and I realize that all my x's are going to be -4. Now some kids like to make like a t-chart, and like they go -4, -4. Like my x is -4 no matter what. So it's going to make this vertical line that goes through x equals -4. So that's why I use the Vux, because it tells me immediately it's a vertical line, and then I can check it with the fact that it says x equals, and that goes with Vux. So take it or leave it. That's how I do that one. Okay, now go to 23. So sometimes kids think 23 might be a Hoy or a Vux, but this has 2 variables. Notice the one we just did had 1 variable. This has 2. So this is in slope-intercept form. It just looks weird because the y-intercept is a +0. It's missing. So you're going to start at 0, and then you're going to use the slope to find more points on the line. So you always put your y-intercept on first, which is at 0. It was missing. And then my slope is 3 over 1. So from here, I'm going to go up 3, forward 1, up 3, forward 1. If you run out of room, you can also go down 3 and back 1. And the reason is because that also gives you 3. It's just you're changing and making them both negative. Okay, once you have, try to get 5 points. You can't always, but once you have those on there, if I had a straight edge, it would be even better. But that is what the graph will look like of that line. And that is a slope-intercept equation. It just looks weird because there's no 0 at the back. Okay, last one. We're going to graph this line. So it's in y equals mx plus b. So this is some other technique you can use if you want to write this out. The slope is -3/4, and the y-intercept is -3. Some kids like to write those out to the side. So my y-intercept is actually a y coordinate that goes with 0, -3. You can think of it like that. That is on the y-axis, and that is always where you start. So basically, you sit yourself on -3 on the y-axis, and then we're going to use our slope. So that negative can go on top or on bottom. I put it on top. So I'm going to go down 3 and then forward 4 and put a dot. Now I'm out of room, so instead I'm going to go up 3 and back 4. And then that's as far as I can go. I can't get any other points on there. Notice that my line goes downhill because my slope is negative. My line on this one went uphill because my slope was positive. And those are examples of how to graph slope intercept, and then one that is not in slope intercept because it's a vertical line.